All right, Chapter 7, Section 4. Double and half angles. All right. If you take a look in the back of the room, you're going to see two posters. One's a half angle identities, one's a double angle identities. All right? We're starting to use these posters in the back of the room a little more. Nope. Nope. Actually, we're going to start off with the half angle first. Half angle identities. We're going to write these out. And these aren't bad to remember. Sine of theta over 2 equals plus or minus the square root of 1 minus cosine of theta. These are half angles. Divided by 2. Okay? And if you need them, go to the back of the room with your phone, take a picture of them so you have them. All right? What do you need? Yes, go ahead. All right? Cosine of theta over 2, or a half angle, equals plus or minus the square root of 1 plus cosine of theta over 2. All right, so you notice that this sine is a minus, cosine's a plus. And they're all one cosine and over 2, right? Tangent is easy. Once you have these two, tangent of theta over 2 is real easy to remember, because it's plus or minus the square root of 1 minus cosine of theta over 1 plus cosine of theta. Now, what would a half angle look like? I'm not going to clear it all. I'm going to use sine, so I'll leave that one up there. If I had sine of 15 degrees, we look up here, and we don't have a good triangle for 15 degrees, do we? Right? We can't find that. But what if we did it as sine of 30 divided by 2 degrees? We do have a good triangle for 30 degrees. We can plop that in. Plus or minus square root of 1 minus cosine of 30 degrees over 2. We look at our 30, 60, 90. 1, 2, oh, this is square root of 3 here. And this is 2. 1, 2, square root of 3. We take a look at 30 degrees. Cosine of 30 degrees is adjacent over hypotenuse, so that's square root of 3. Plus or minus 1 minus square root of 3 over 2 divided by 2. Is that good enough? No. If I'm going to reduce this, I'm going to put this 2 over 2 right here instead of 1. 2 over 2. This would be 2 minus square root of 3 over 2 divided by 2. I take the bottom one, invert it. Really? Wait till I'm done. Minus, it would be 2 minus square root of 3 over 4. Invert it, right? This is 2 over 1 right here. So I invert it and multiply. Truthfully, I'm not done, but I'm going to leave it there. I can't really leave it in a form like this, a fraction over a fraction. But if I have it just in a fraction form within it, I'm good. That's as far as you need to go with it. All right? I don't want it in a fraction over a fraction. Okay? Sure. You get it wrong, but you can write 1 for the answer. Okay? Maddie, real quick. If I was to give like sine of 15 degrees, that's the same, and I don't have a triangle that works with 15 degrees, but I do have one that works with 30. So I can make this 30 over 2. Now I know what my theta is for each one of them. Okay? That's the essence of the half angle. All right? Any questions on that? The tough part gets down into here, right? Doing that stuff. Everything else. What's that? Sure. You want to do another one? Tangent? Sure. Tangent's just with the half angles real easy. Let's do tangent of 22.5 degrees. No, it's not. Yeah. Same thing as saying tangent of 45 over 2. Right? No, heck no, it'd be really hard. Yeah. 1 minus cosine of 45 over 1 plus cosine of 45. What's cosine of 45? 1. No, it isn't 1. Cosine of 45. Come on, you guys. Yes, it's always. Remember, 45 degree angles are 45, 45, 90, right? So cosine and sine are always square root of 2 over 2. One minus square root of 2 over 2. 1 plus square root of 2 over 2. No, they don't, Maddie. Sorry. Can't do it. And actually, when you start reducing this is getting a quagmire real quick. This is 2 minus square root of 2 over 2 over 2 plus square root of 2 over 2. 2's cancel out here. We're left with square root of 2 minus, or 2 square root of 2, 2 plus square root of 2. Are we allowed to leave a square root on the bottom? No. Do you want to know something? And this one here, I'm leaving it there. That's legal in the math world in my book, because that would be What would I have to multiply the bottom by? Does anybody tell me? There you go. 2 minus the square root of 2. 2 minus the square root of 2. So what ends up happening? Plus or minus? I'm going to get 2 minus the square root of 2 coming out. Right? And inside's going to be 1 over 4 plus 2. So it's going to end up being plus or minus 2 minus square root of 2, square root of 1/6. Am I done there? No. I've got a square root on the bottom of the 6. Yes. So then I would be, watch this now. So this is going to be plus or minus, oh, not square root, this is just parentheses. Parentheses, 2 minus square root of 2, square root of 6 over 6. That's done. That was done. Guys, right here is all I'm going to require you to do. The rest of this, no, the rest of it, this is illegal. This is legal.
We're doing that illegally. We're so bad.
Yes, this is legal. That is doable for me. All right. Do we have an understanding now? All right, let's get into double angles. Double angles. Sine of 2 theta. Yes, double angles. Sine of 2 theta. 2 sine of theta. Cosine of theta. 2 sine of theta. Cosine of theta. Do you guys remember when you had 2 separate angles? If I was going to do this, sine of theta plus or minus beta, what that equation look like? Remember that? This would be sine of theta cosine beta plus or minus, well, this is going to be on your test. Cosine of theta sine of beta. Okay, what if my angles are the same? Watch what happens. If this isn't beta, but this is theta. Theta and theta, right? Or alpha. I'm sorry, alpha. I'm alpha in here, not theta. What happens? I can't really subtract these two because then they'd go away, so the subtraction goes away on this. It'd just be 0. So it'd be like adding them, right? What's this? 2 sine of theta, or of alpha, cosine alpha. There's your, that's how you get your double angle. All right. All right. Can we take cosine? Let's take cosine of alpha plus alpha, right? Let's derive our double angle for cosine. What is it? It is cosine of alpha, cosine of alpha. And it's the opposite of this, right? We got plus in here, so we have to say minus. Sine of alpha, sine of alpha. What do we have? Cosine squared of alpha minus sine squared of alpha. This is your cosine of 2 alpha. Double angle. Now, if you take a look on the chart back here, you're going to notice that they have 3 different ways of doing this. They got cosine squared of alpha minus sine squared of alpha. How do they come up with 2 cosine squared of alpha minus 1 and 1 minus 2 sine squared? Well, take a look at your original Pythagorean identity. Sine squared theta or plus cosine squared of theta equals 1, right? Let's substitute out my sine. So sine squared of alpha equals 1 minus cosine squared of alpha, right? Or in this case, theta. So let's plug that in. Cosine squared of theta, or alpha. Michael, do you see what I'm doing? Okay. Well, see what I did? I took the original Pythagorean identity. Okay. Mike, took the original Pythagorean identity and I just solved it for sine. Then I'm going to take this and I'm going to plug that back in there for that sine. So sine squared of, and I'm using theta here, but we're using alpha up there. Oop. Alpha up there, right? And I put this in up here. I'm going to minus 1 minus cosine squared of alpha. You see what I did, Mike? Carry this through. Cosine squared alpha minus 1 plus a cosine squared of alpha will equal 2 cosine squared alpha minus 1. So what we've done is we've taken the cosine here, and we developed another solution for a double angle. How do you think they got the 1 minus sine squared? They solved the cosine. They solved for sine, or it's called for cosine, and put it in there. Do you see what? Do you see what we're doing? You see what we're doing?
Like I get how they got the 3 of those, the 3 from the 1.
Cosine. All right.
I got that part.
All right. You see what we're doing, Kayla? All right, Maddie? All right, good. What if we had the tangent of alpha and beta? Tangent of alpha and beta. What do we have here? We have the tangent of alpha plus, now I'm not going to subtract these, so I'm going to get rid of these minuses. Tangent of beta over 1 minus tangent alpha tangent of beta. Well, let's get rid of the beta and make it alpha. So it's going to be like 2 alpha, right? Switch that out. Tangent of alpha plus tangent of alpha over 1 minus tangent of alpha tangent of alpha. On top is 2 tangent alpha. On the bottom, 1 minus tangent squared of alpha. All right. That is our other double angle for tangent. No, it isn't. It's 2 tangent. Yeah, tangent squared on the bottom. So we can figure out what our half angles are here. Our half angles. Actually, guys, you want to know the truth of it is, I can derive the half angles the same way. Yeah, I'm not going to derive it for you, but you can do it the same way. All right, let's take a look at what we have for problems and what we're going to be doing. Okay. If you take a look on page 382, number 17, it tells me at top, it says tangent of y equals 5/12. What kind of triangle am I looking at? 5, 12, 13. Okay? Now, tangent is what? Tangent is opposite over adjacent, right? Opposite over adjacent. So, if I'm looking at the opposite of 5, I'm looking at this angle right here. I've just determined which angle I'm looking at. That's all this tangent of y is telling me. It's setting up the triangle for me. All right? It's just setting up the triangle. Now we take it and we go sine of 2y. And we have to figure it out. What is the double angle for sine? All right. There is the double angle for sine. What's my sine in here? What's my sine of y? Because that's what I gave you. It's number 17 in your book. It's the first one. It's opposite over hypotenuse. What is opposite this angle? 5 over 13. 5/13. What's my cosine? 12 over 13. You see how we get this? What's that? All right. Multiply 2 times 5 is 10 times 12 is 120. 13 times 13 is 169. There is your answer. That's how we figured out the answer. You guys have 18, 19, 20, 21, and 22 to do. 18, 19, 20, and 21 to do. What's that? All right. 382. This is only part of it, guys. 382. 18 through 21, is it? 22. 18 through 22. All right. That's part of it. You guys got that written down? Michael, have you got it written down? Number 23. Now we are working on the half angle. So I've got sine of 105 degrees. What are we really looking at? We're looking at the sine of 210 degrees over 2. Where does 210 fall? Right here. 30 degrees down from the 180. So we're actually looking at a 30-degree angle, all right? And we're looking in the third quadrant. The only thing positive in the third quadrant is tangent. So this is going to end up being a negative. So what we're really looking at here is a negative sine of 30 over 2. Yep. So in this case, it's going to be a negative 2 sine of 30 cosine of 30. Which is going to equal same as what we did before, right? Looks the same, doesn't it? Oh, no, it doesn't, because I'm using double angle. I'm using the wrong one here. Excuse me. This is half angle. This is half angle. Yep. So for the sine of this is going to equal plus or minus square root of 1 minus cosine of 30 over 2. Cosine of 30, square root of 3 over 2, plus or minus square root of 1 minus square root of 3 over 2, and then we reduce it down. All right? You guys have 24 through 28 to do. So 382, 24 through 28. And also, 19 through 22.